Hey guys, this tutorial concerns Thursday's homework. That would be comparing and scaling page 31, numbers 3, 5, 6, and 13 through 15. Now I am going to let you know this. I'm going to leave 13 through 15 up to you, but I am going to kind of go briefly into numbers 3, 5, and 6 so that we can get a good general idea of what it is necessarily that they're asking us to do. Now after reading problem number 3, and I'm going to expect that you've done that on your own, what they're going to ask us is, if we're going to throw a party, which store should we go to get the better buy on some avocados? Now the real question here is this: if we're getting at one store 7 avocados for $6 and at the other store 5 avocados for $4.50, asking for which is the better buy, okay, doesn't matter how many we buy. The question is, how much are we paying for one avocado in the whole scheme of things here? You're going to notice that at both of these stores, I've actually written these things as a ratio. Now I know 7 avocados are not equal to $6, but they are equivalent in the sense that we can compare these two things. Now the big question is this: the better buy would be the one where we're paying the least amount for one avocado. So what we're going to look for here is what we call a unit rate. When we compare two different units, we call that a rate instead of a ratio. It is a ratio, but it's a specific type of ratio. We call it a rate. When we look for a unit rate, we're concerning ourselves with how much it would cost or how much one thing you would get for one of the other. Okay, so in this case I want to know how much for one avocado. So here's what I could write underneath. Now this is a nice way of diagramming this, but I would say 7 avocados is to $6, as one avocado would be to how many dollars. Now looking at several problems like this in the past, you might say, okay, well, you know, let's find a scale factor. The neat thing about finding unit rates is it does involve the integer 1. And that's nice because I know that the scale factor from 1 to 7 is times 7. Of course, we know that if we took this number times 7, we would get 6. Honestly, though, we want to work backwards from 6 to 1. So if going this way is times 7, going the other way around would be times 1/7. 1/7 being the reciprocal of 7. Now, some of you are saying, but I don't want to multiply by fractions. One cool realization that we made way at the beginning of the school year is that multiplying by a fraction is the same as division. So what we'll do here is, working our other way around, we can say 7 divided by 7 is 1. So let's take 6 divided by 7, and this should reveal what we would be paying for one avocado at this particular store. Doing the same process over here, we say 5 avocados for $4.50. Well, then one avocado would be, I don't know, dollars, okay? Finding a scale factor, this way would be times 5, from 1 up to 5. So let's take 5 divided by 5 to find this unit. We would also take 450 divided by 5. I will admit this, it is much easier to divide 450 by 5. One way to think about it is we're dividing 45 by 5 and adjusting the decimal. But that's how much it would cost for one avocado. Question is, which store offers the better price for one avocado? So we find that unit rates are very, very useful much of the time. Moving on to number 5, you're going to notice this. They spoke about an advertisement that we had run into in our Bolda-Cola investigation at the beginning of this entire unit. Anyway, what they do is they hook you up with two different ratios, one ratio being 3 to 2, meaning for every 3 of this thing, there were 2 of this thing. Of course, one important realization that we have to have here is that there were 5 total. Not that that has any bearing on this problem, but you need to remember that in this ratio, it's a part-to-part ratio, so the total is these two combined. They also say that 17,139 compared to 11,426 is an equivalent ratio. So these two ratios form a proportion since they are equal ratios. One cool consequence of them being equal ratios and proportional is, think back to our last unit, stretching and shrinking, where you're very, very familiar with the concept of similar shapes. There has to be a scale factor if they're proportional. So yes, we'll admit that there is a scale factor from 3 to 2 up to these two quantities, which means there would be one number I could take these times to get these. That being said, who cares about that? Here's what they're going to ask you to do. They're going to ask you to provide, I think, 2 or 3 more ratios that would be equivalent to these two. And of course, if these are both equivalent anyways, let's choose to work with the smaller one. This is very, very similar to problems I've given you in the past where I say, here's a shape, draw me another similar shape. What I'm asking you to do now is I'm saying, here is a ratio, give me another equivalent ratio. We know that equivalent ratios that are proportional have to have scale factors. So basically, here's the challenge to you. I'm saying, choose a scale factor and totally multiply both of these numbers by that same scale factor. We know that the new ratio must be equivalent. Okay, another way of expressing this would be as a fraction. Now, although this doesn't mean 3 out of 2, what I would ask you to do is come up with another fraction that's equivalent to this. So we would find a scale factor to multiply these both times, the top and the bottom times, to get this new fraction. Of course, we know we could always check that with the cross product to make sure that the cross products are equal. Lastly, on number 6, what they've done is they've given you a situation where there's a class. I think they mentioned Miss Torini's home room has 18 boys and 12 girls is what it says here. They're going to ask you for ratios. Now, the interesting thing about this problem is if you're tuning in, then you're going to know fine and well that I'm going to ask you to write these ratios. But me, personally, I want all ratios and fractions reduced. So on question A here, it says, what's the ratio of boys to girls in Mrs. Torini's homeroom? A ratio is merely a comparison. We're comparing boys to girls. So I'd ask you, how many boys are there? There are 18 boys. And I do, in this situation, just so that we can be clear about it, label it. Write 18 boys to 12 girls. Now, one thing to point out is, on part B, they say, what's the ratio of girls to boys? Order does matter in the ratio. So if they say girls compared to boys, we would simply switch these two numbers around. Now looking at both of these, and I did not express this as a fraction, but you'll notice that they are both even. So simplifying this, at least if they're both even, we can split them both in half and say a simplest form equivalent ratio might be 9 boys, 9 because that's half of 18, 9 boys for every 6 girls, which is half of 12. Now you might notice already in the beginning that actually the greatest common factor between 18 and 12 was 6. Feel free to go ahead and chase after that greatest common factor first, because it's going to save you more work, which I actually have to do right now. Because I chose to divide by 2, I still need to divide both of these by 3 since they are multiples of 3. However, if I would have divided these both by 6, it would yield the following ratio that we're about to find. So we would say, okay, 1/3 of 9, or dividing by 3, would be 3 boys, and 1/3 of 6 is 2, to every 2 girls. Now I know that these are not the same ratio, but they do represent the same balance, so we say they are proportional. So us stating that for every 3 boys there would be 2 girls would be about the same situation, or is the same situation as saying, well, for every 18 boys there were 12 girls, and vice versa. Okay, so use that, but here's what I want you to know. You need to be simplifying your ratios on number 6, if at all possible. Have fun on the homework.